Today we're going to be talking about solving systems of equations. Before you begin solving your systems of equations, you want to first decide what kind of solution they're going to have. We have three different types of solution. One solution. The lines intersect at exactly one point. The slopes of the lines are not the same. You'll see in our example that our slopes are 4 and 2. So there's only going to be one solution. No solution. The lines are parallel and never intersect. The slopes of the lines are the same, but the y-intercepts are different. Same slope, different y-intercept. Then you can have all real numbers, infinite many solutions. This means that the lines intersect everywhere. The equations represent the same line. You have the same slope and the same y-intercept. Once you determine what kind of solution you will have, then you can decide whether or not you need to continue by solving your system of equations. The first method we can look at is graphing. X minus 2y equals 6, and 3x plus y equals 4. To solve this, I know that the slopes are different, so I can go ahead and find the point where they intersect. Before I begin, I want to graph my lines using slope-intercept form. So that's what we'll do first. Let's start with the first equation. X minus 2y equals 6. And let's put this in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. We can subtract x from both sides. And divide both sides by negative 2. This lets me know that my slope will be 1/2 and my y-intercept is negative 3. We can do the same thing with our second line. 3x plus y equals 4. Subtract 3x from both sides. And we have our slope-intercept form. Slope is negative 3, and our y-intercept is 4. Now we can graph these two equations. Again, our two equations were y equals 1/2 x minus 3 and y equals negative 3x plus 4. We'll start with our first line. Our y-intercept is negative 3. So that's where our line will cross the y-axis. I need to rise 1, run 2. Rise 1, run 2. You can continue this as many times as you'd like. Let's graph line 2. Our y-intercept is 4. My slope is negative 3. Rise negative 3, run 1. Once you do this, you can find your point of intersection. This is the point 2, negative 2. The solution to your system of equations is 2, negative 2. Let's try a different method. Our next method will be elimination. The goal is for the coefficients of either the x's or the y's to be the same number, but with opposite sides. First, make sure that both equations are in standard form. ax plus by equals c. Both of our equations are already in this form. Decide if the x's are to cancel or the y's. It doesn't matter. You just simply choose one. choose to eliminate the y's. This looks like it'll be simple for me since they're already opposite signs. Determine the least common multiple of the coefficients of the y's. Since I have a coefficient of negative 2 and 1, I'm going to use the least common multiple of 2. To make these 2, I multiply the bottom equation by 2 so that the coefficient of y will be equal to the LCM. Next, add the two equations. X plus 6x is 7x. Negative 2y plus 2y will cancel out. 6 plus 8 is 14. Now we solve for x. Undo multiplication by dividing both sides by 7. X equals 2. Choose one of the two original equations to use for this next step. It does not matter which one is used. I'll choose the first one. The first line was x minus 2y equals 6. Since I've solved for x, I know the value that can be plugged into this equation. Plug in 2 for x and solve for y. Subtract 2 from both sides. My 2's will cancel out. And I'm left with negative 2y equals 4. Solve for y by dividing both sides by negative 2. So y equals negative 2. The ordered pair is x equals 2 and y equals negative 2. If the lines were graphed, the point of intersection would be 2, negative 2. Let's try our third method, substitution. The idea here is to solve one of the equations for one of the variables and plug this into the other equation. Again, it does not matter which equation or which variable you pick. There's no right or wrong choice. The answer will be the same regardless, but some choices may be better than others. I'm going to choose to use the second equation. 3x plus y equals 4, and I'm going to choose to solve for the y. To solve for the y, I'm going to subtract 3x from both sides. This leaves me with y equals negative 3x plus 4. Since I've solved for y, I'm going to use this value and plug it into the opposite equation. So instead of plugging into the second equation, I need to plug it into the first equation. X minus 2y equals 6. My value for y is negative 3x plus 4, so let's plug that in. Now we'll just start to solve for x. Combine like terms. X plus 6x is 7x. Add 8 to both sides. And divide both sides by 7. X equals 2. I have my value for x, so I'm going to plug this back into my equation y equals negative 3x plus 4. This will tell me what my y equals. Negative 3 times 2 is negative 6. and negative 6 plus 4 is negative 2. My ordered pair will be 2, negative 2. The last method we can use is just our calculator. First thing we want to do is write the equations in slope-intercept form. Slope-intercept form is y equals mx plus b. So we need to solve for y. X minus 2y equals 6. I can subtract x from both sides to get negative 2y equals negative x plus 6. And then divide both sides by negative 2 to get y equals 1/2 x minus 3. Let's do the same for our second equation. 3x plus y equals 4. Solve for y. Subtract 3x from both sides. And we have our equation in slope-intercept form. Y equals negative 3x plus 4. Let's get out our calculators. Since we've solved for y, we're going to push our y equals button. Make sure your calculator is cleared out. Let's plug in our first line for y1. 1/2 x minus 3. For line 2, negative 3x plus 4. We wanted to look up a table for this. Second graph will show us a table. Scroll up or down until a row is found where the values of y1 and y2 are the same. On your calculator, you will see that y1 and y2 are the same when x equals 2. This shows you that x equals 2 and y equals negative 2. So your ordered pair is 2, negative 2. Now that you've seen all 4 methods of solving systems of equations, choose the one that's the most comfortable for you and use it often.